So, Chapter 6, Practice Exam 3. You'll notice that I've already completed number 1 over here. It's because I did it and I made a mistake. And so I fixed my mistake and I'm just going to redo the video with my correction in there. So, we've got a young couple that is saving money in an account to pay for their 4-year-old son's college. And so they invest an initial lump sum of $3,000 at 6.5%, compounded quarterly, and plan to continue contributing $1,200 every quarter. And so we're wondering how much will be in the account 14 years later when this young man is 18 years old and ready to go to college. And we're wondering how much money the family gained by doing this. And so I'm going to sort of quickly run through this one. You can see here I've got my SERM tin with all my information. And I made a mistake when I did this the first time. I actually put 12 right there instead of 4. And I kept getting an answer that I thought was way too low. And it was way too low because there needs to be a 4 there, not a 12. This is not monthly, it's quarterly. And so we need for this 2 separate equations because this $3,000 lump sum is going to grow by compound interest. And this $1,200, because it's repeated payments, is going to behave like an annuity. And so we're starting with the $3,000 with compound interest over here. Got our information in there, and this $3,000 over 14 years ends up growing to be $7,398.65. So again, this $3,000 is a lump sum, so compound interest is the formula we need to use with it, and we end up with $7,398 resulting because of that investment. Now the second piece of this is a future value of an annuity, because we are making regularly scheduled payments of $1,200 every quarter. And so you can see I've got my $1,200 here. Interest rate is 6.5%, compounded quarterly, and it's going to be doing that for 14 years. So I did leave this as a fraction because, and I have another typo in there, don't I? I've got a 12 over there in my, this is like, this problem is causing me great pain, everyone. So there we go, 0.065 over 4. I'm going to pause this video really quickly and check with Wolfram and see if I put the typo in Wolfram too, or just in my writing. So no, the typo is just in my writing. I did put the correct thing in Wolfram with it being over 4, there and there. So always something. And that ends up growing to be $108,274.48. So we throw that into our future value of annuity, we get this. And so we have the value of these 2 investments combined. So we've got this one, which was the $3,000 that they started putting away at the beginning. And we've got this one. We're going to add those together to get the total value that's going to be in this account. So the amount that grew from the compound interest and the amount that grew from the annuity. And so the total amount in the account that we end up with is going to be $115,673.13. And so that answers the first piece, how much is going to be in the account. And then the second piece, how much did the family gain by doing this? And so just by doing some simple math, the total deposits were the $3,000 initially, and then the family did $1,200 every quarter for 14 years. And so if I do the math in Wolfram and I add all that up, I get $67,200. And so it's pretty awesome that these people only put in $67,000 and they're going to have an account that has $115,000 in it. Now, I didn't continue with this problem beyond this point, but if we wanted to play this out a little bit further and talk this out more, we could say, hey, they're probably not going to take the entire amount out of the account all at once. So they're actually going to end up with more than $115,000 if they just take it out in pieces, because remember, what's left in the account after you take money out continues to grow. And so when the child turns 18, though, they are going to have $115,000 in there, and it'll be a gain of about $50,000 for doing nothing. So that's it for problem 1. Get me out of this problem. I keep making mistakes on it.